where, well, let's find out what it actually is. So so B, what did we say B was? Does it matter? I could have either, right? Did I specify I? Don't think it matters. Well, anyway, I mean, yeah, we've found elements that do not belong to H. Therefore, H is not normal. Right? Question 7. I'll just do this verbally. It's a true and false. Barnard likes true and false type questions. Okay, true or false? Two cosets are either identical or disjoint. Well, remember your theory about cosets? They are either identical or disjoint, so that's true. Okay. Part 2. No two cosets have the same number of elements. Well, all cosets have the same number of elements, so that's obviously false, right? You can combine any two cosets using the rule induced by the group. Yep, that's what I call subset multiplication, right? By taking any element from the first and combining it with any element from the second, and finding the coset which includes the resulting element. Yes, that's how you go about finding the binary. That's the result of the binary operation between two cosets by doing just as he said. So that's true. All right. All right. I'll do the last one. It's question 9. Let G be a group. Prove that H is a normal subgroup of G if and only if every right coset of H in G is also a left coset of H in G. Okay, I'll say that again. It's question 9 of the questions at the back of the end of chapter 17. So G is a group, right? H is a normal subgroup. H is a normal subgroup of this group G. Okay, if and only if every right coset of H in G is also a left coset of H in G. So so if H is normal subgroup, a left coset in that group is the right coset, and vice versa. So, all right, now it's an if and only if. Well, give me a bit of space. I think I got robbed with my first whiteboard. It was probably just some Chinese fake. China's full of fakes. There's not enough law here. People don't respect the rights of the individual. I'm really quite critical of it as a Westerner. I talked to a professor of law at one time, a couple of years back. I asked him how many lawyers are there in China, and he said about 300,000. But the country needs about 10 million. So, just the whole idea of law and law abiding is highly underdeveloped in China. So I'm really quite critical of it. It's just cheating and thieving going on all the time. I really despise it, frankly. I despise it. Okay. So assume H is normal. Right? H is normal if and only if the left coset is the right coset. So Hx equals Xh. Okay. Alright, so that's statement P. This is statement Q. And start with the if. And so P is true if Q is true. Therefore, if Q, then P. So Q. So from right hand side, prove left hand side. Okay, so we start with Q. So the right coset is equal to the left coset. Now that's true. Pre-multiply both sides by x inverse, so you get x inverse h equals x inverse xh, which is EH, which is just h. Right? So x inverse h, x is h. Now that's the definition of h being normal. So that implies that h is normal. Right? H is normal. So that's statement P. That's P. Okay, so we've proven the if side. Now the only if. So P only if Q. So the only way you can get P, so if you've got P, the only way you can get P is if you've got Q. So if you do have P, you must have had Q. So if P, then Q. Right? So from left-hand side to right-hand side. Okay, so H is normal. We start with that. And we have to show this. H is normal. And that means that x inverse hx is just h. Right? That's the definition of h being, the subgroup being normal. Well, pre-multiply by x on both sides, so you get x inverse h, x equals xh. That's just this here. But this becomes e hx, which is just hx. So therefore, hx, which is this, equals xh. Alright, now let's analyze this a little bit. What is this? It's a left coset. Sorry, a right coset, right? Because this is an element of G, and you're multiplying on the right side of your subgroup H. Okay, so that's a right coset, and this is a left coset, and they're equal. So for and it's for the same x. So for a given, for some specific x, some element. So for a given right coset, there's a corresponding left coset, and they're equal. They're equal. Okay. So you've got Q. Yeah, that's Q. So from P to Q. So we proved it. Now that's sort of interesting. It gives you, the fact that you got this, that if H is normal, then the right coset is the same as the left coset. That's quite interesting, because it gives you another way of looking at what H is. So a normal subgroup, for a normal subgroup, its left coset, for any left coset, that left coset is equal to its right coset for the same element, x. Okay, that's a different way of looking at what a normal subgroup is. Instead of thinking in these terms, right? Another way, an alternative way of thinking of what a normal subgroup is to think of it in these terms. In other words, its right coset, for a given x, is equal to its left coset. Right? So that's worth keeping in mind. It's quite useful. All right. So that's the end of the problem solving. Now, for the next lecture, it will be on homomorphisms. Now, you probably can suspect that homomorphism has sort of related to isomorphism. Now, what's the difference? They are related, of course. Homomorphisms are a kind of mapping, just like isomorphisms are. The difference is, with isomorphism, you're mapping like one-to-one, one thing to one thing. Homomorphism, you're mapping many, or you can, mapping many to one, right? And still, so in effect, you can take a large group and map it into a smaller group, right? That mapping Like you can take several group elements of your bigger group and map them into just one element of your smaller group, right? And there's a whole bunch of mathematics about that, including new concepts that result because of this many-to-one mapping, right? And that many-to-one mapping that preserve the, how can I put it? I won't go into too many details, it's like for next lecture. But homomorphism is effectively many-to-one mapping so that the corresponding properties of the two groups remain in correspondence. I'll be as vague as that. So that will be for next lecture, next chapter. So, ciao.